Hi, I'm Kevin Cochrane, and I'm the Chief Marketing Officer here at Vultr. Vultr is the world's largest privately held cloud infrastructure provider specializing in cloud GPU. And I'm excited to speak with you all today around generative AI and the new multi-cloud imperative, composable infrastructure. Before we begin talking about composable infrastructure, I wanted to take you back in time for lessons learned from the past as we embark on a new era of cloud compute. Our journey begins in 2000 when organizations started to go mainstream with their first web application architectures and started to build out all of the build, test, and production deployment environments globally in order to build a new generation of web applications. If we roll the clock forward 10 years, we started to see mainstream adoption of cloud infrastructure for new cloud native application architectures where people were leveraging low cost at the time cloud compute in order to distribute production workloads across a global workforce and global consumer community. Now we are at the dawn of a new era of cloud compute, where GPUs are at the core of accelerating new types of workloads, specifically to advance new AI and ML initiatives. And in this new era of cloud compute, one of the lessons learned from the past is how do we avoid what has become known as the trillion-dollar paradox. With cloud infrastructure, the promise was to quickly hyperscale our business. But one of the things that has been learned is that we increasingly realized a hyperscaling of cost and complexity. This trillion-dollar paradox meant, simply put, that the cost of cloud operations almost precluded successful scaling profitably of our businesses. In one of the most egregious examples, we saw the case of Dropbox, which started the process of repatriating their workloads to their own co-location facilities, and in so doing had dramatic cost savings of $75 million over 2 years and a market increase in margins. The promise of the cloud was always to provide the lowest cost way to very quickly scale our production workloads. But increasingly, what we saw in the past 10 years, a consolidation of cloud infrastructure providers, meant that we wound up being overbilled, overcharged, and having overly complex infrastructure that locked us in. Again, we're in a new era of cloud infrastructure and embarking on a new digital frontier with massive innovation in the underlying GPU infrastructure that is unleashing a wave of innovation in new large language models and other supporting infrastructure to truly make AI and ML the promise of the future. And currently today, in this mad rush to unlock the benefits of AI ML, companies are looking to move very, very fast, specifically to get access to the latest generation NVIDIA GPUs for their production workloads. And what many organizations have found is that procuring and deploying and configuring those GPUs in their data centers was simply not fast enough. The time it takes to both source and provision GPUs and make them ready for use for ML engineering teams simply meant that time to market was too long. What this has driven is a massive urgency to accelerate AI ML by leveraging a cloud GPU model. Simply put, this takes out all of the complexity and the time delays for configuring and provisioning in your own data centers and relying on cloud vendors in order to quickly spin up your GPUs. But one thing we've also learned is that this process alone is simply not fast enough. The complexity of the GPUs is not only in securing and provisioning them, but it's also configuring them to make them make productive use of your workforce. Simply put, ML engineers are not systems administrators, and making sure that the GPUs are ready for people to begin immediate productive use by configuring all of the drivers and all of the necessary supporting infrastructure is a key requirement. Greater complexity in the pace of innovation in GPUs and pace of innovation in the supporting drivers and software infrastructure means a faster time to market model is needed. To move fast, we have to take away the systems administration pain. We truly need on-demand cloud GPUs that are pre-configured for instant on, so ML engineers can immediately spin up their Jupyter notebooks and begin working with the latest and greatest models and begin fine-tuning and pushing to production inference all of their tuned models to support all of their new AI ML initiatives. If the process takes longer than 20 seconds, it's simply not fast enough. Beyond the core requirement for training, however, is a bigger and broader requirement. Again, a lesson learned from earlier epochs of web infrastructure. We need to think beyond just the training clusters we're spinning up, but we also need to think about how we can actually fine-tune those models on localized data sets in region, and then also push those tuned models to production inference as close to the edge as possible, ideally co-resident with our cloud-native application code, so that people that are accessing our new services on their mobile phones or on their desktop have the best performance and the greatest responsiveness, and also delivered at the lowest cost with no latency and no round tripping to backend servers, oftentimes on another continent. We need to have a truly global architecture and a true life cycle for managing the spinning up of GPUs instant on for productive use by our ML engineers that can also be pushed to regional clusters for tuning and ultimately to a worldwide global network of inference servers to support your employees and your customers wherever they live and work. And in so doing, we need to also make certain that we avoid the next trillion-dollar paradox. And that trillion-dollar paradox is a potential consequence of what we're seeing with possible consolidation of core AI infrastructure, once again, in the big three hyperscalers. Simply put, the cost of leveraging the pre-built models from the hyperscalers may wind up leading to a significant hyperscaling of costs that lead us right back to the same problem we saw with core cloud compute, where we had escalating costs and complexity that ultimately left us with the trillion-dollar paradox and a decision point on how we optimize our workloads and which workloads we deploy in the cloud versus which workloads we repatriate to our local data center. Simply put, the cost of these pre-built services and the ever-growing complexity and interdependencies between them face a risk to the ongoing scaling profitably of our business models. So the countervailing force is the massive innovation coming out in the open source community. The whole goal here is to move away from thinking about an all-in-one LLM model that will ultimately lead to the same lock-in that we found in the earlier era of cloud compute. The all-in-one LLMs can lead to an exorbitantly high cost of production inference with significant security, privacy, and compliance risks for training on your own data sets. Oftentimes, these generalized models can also have higher rates of hallucination and random bias. And obviously, as an all-in-one model that's just limited to some third party that you're contracting with, means that you don't have as high a degree of control in terms of adhering to NIST standards around explainability, meaningfulness, accuracy, and knowledge limits. Within the open source community, however, we're seeing an explosion of innovation of purpose-built LLMs that can give you freedom and flexibility. Their compact size leads to faster response rates, lower costs, enable domain-specific tuning, and allow you to tap into rapid evolution to control your own destiny, and most importantly, avoid lock-in. What we believe here at Vultr is that to truly accelerate AI ML and to achieve a new era of cloud compute, a GPU accelerated era of cloud compute, we need to move to a fully composable model where all cloud services are modular, atomic, orchestratable. And the most important thing is eliminate any and all dependencies so that you don't become locked in like in earlier eras of cloud compute to a singular provider and not just get locked into the core infrastructure, but locked into all of the pre-built AI services that essentially wall you in. So what we believe very strongly is that to move fast, not only now, but to move fast in the future, we truly need to unlock the benefits of multi-cloud and actually move to a fully composable cloud GPU model that locks in the benefits of open source innovation, locks in the true benefits of multi-cloud, delivers true infrastructure as a code, and again, eliminates any and all cost and complexity for consolidating cloud infrastructure and AI ML service providers. What we believe pretty strongly is that we need to have a new global GPU architecture where you can instantly spin up your core training clusters on demand with instant and ready access for all of your ML engineers to begin productive work. And then most importantly, also be able to tap into all of the purpose-built open source LLMs through a public registry so that you actually have the lowest cost, fastest way to get time to market and control your own destiny. Moreover, we believe that the entire application lifecycle needs to be orchestrated so that those trained models can then be immediately published and made available in local regions to be tuned against local data sets. And then again, to be immediately published and made available to different instances of specialized GPUs optimized for inference as close to the edge as possible. A little bit about Vultr is we believe very strongly in pioneering this new epoch of GPU accelerated cloud, leveraging the best of open source innovation and unlocking the true potential of AI ML and all of the new LLMs that are coming to market, and putting in place a composable infrastructure that enables you to spin up and spin down on demand at the lowest possible cost with zero complexity and zero lock-in, all of the instances needed for training, for tuning in region against localized data sets, and for pushing your fine-tuned models out as close to the edge as possible across 32 regions and all 6 continents to drive production inference without the incredible exorbitant cost of pre-built models from the big 3 hyperscalers. So with that, I'd like to say thank you so much for your time today, and I look forward to discussing more about a GPU accelerated cloud with you in the future.